A very good evening, sir. I'm Naguli Suresh from pre-BEEA S1/1. Today, I would like to explain the lab for introduction to 68K simulator. Then we go to the procedure 4.1, Introduction to the Easy 68K Assembly Language 2. To begin the season, run the program edit 68K. This is the text editor 68K assembly language program. This is the following screen. Then this code in this window provide a template for your own program. You can erase this code and start again. You can use it. Then consider entering a program to display hello world below. This is the code. Okay. This is the code that we entered by the procedure. Then we need to assemble, source and execute the program simulator. Then we can see this screen which is show the simulated register and the first line of the code. Then to run the button, we assemble the button, then we can show the output window which is hello world. And then now show the step 12 we show the remove line, message tcp dc.p hello world and add the below code previous program after removing step 12. This is the following screen which is show the program code after removing step 12. In the simulator window, we can select the new. We can we assign first we assign the source execute and we select the view memory. The memory window will pop out as below. Observe the machine code that has been loaded to the memory. Then in the report explain the what happened when execute your code in the step 13. dc.p hello FTK student CRNF and dc.p microprocessor technology 68K 0 are our string variable which called as message initializer fearless by dc.p and the end and at the end it has the null terminator 0. Zero terminator is necessary for the printing subroutine to know when to end printing. Then at the last of this part we should run the program. Then the output window show the hello FTK student microprocessor technology 68K. Thank you. So
Good evening, sir. I'm Yashiki. I'm going to explain lab 4 from Procedure 17. So procedure 17, they ask us to add redo code to previous program after the line. After done the task 2, so we will do the task 3. They ask to add this code into our software. So this is the software that we use. This is the code. So they asked us to assemble and execute the code to show the output. So for that, we need to assemble the source and we'll execute. So once we execute, it'll come out another template showing the code, the addresses for code line by line. And then once we run, so this is the output. It shows that hello FTK students, Microprocessor technology, and this program shows to how to write, assemble, and run program. So you can also make multiple lines in one DC. So this is the output that we obtain. Okay. For procedure, and then for procedure 90, they ask us to label what is CR and LF, and also it labels the functions. Okay, so CR is the carriage return, and they will be in hexadecimals, 13 in decimals. So the function is to move the cursor to the beginning of the line without advancing to the next line. So LR will be the line fade. So in hexadecimal, 10 in decimals. So it's moved the cursor down to the next line without returning to the beginning of the line. So for procedure 20, they ask us to observe and the contents, and also ask us to each instructions to be execute. So this is the lay message A1 move dot b. So the data register D0 will be the, this is the first line. So from here we know already. Uh, okay. So from here we can see that the first line will be 0000. So this is data register, and the Lee message will be here, and the addresses for the Lee message will be 0001000. And for then they ask for program counter. So for program counter, we will take the second addresses, right? For Lee message will be, what is that? Okay. So for Lee message will become 0010006. So we will take the second addresses compared to the first addresses. Okay, that's similar for rest of the contents. And then, okay, for question 1, they asked to explain briefly the operand of the following instructions. So the Lee instructions places the address specified by its first operand into the register specified by its second operand. So this is the syntax for the Lee. And move.b will be the move will be copies data from one location to another and will be qualified by b to move 8 bits. So the source will be the destinations, and the syntax will be the move. And then for trap, it actually causes a trap vector exceptions. The instructions adds the immediate operand vector of the instruction to 32 to obtain the vector number. So they will have used the bit of SR. So this is the trap, the coding now. And then for a dc.b, it's to define the constant in memory of length 1 byte. The relative address of the first case of a data defined by a DC statements can be referred by an operational label. So if a length extensions PW or L is not specified, the bytes value is used for a string and the word will for a numeric data. So this is the syntax for the dc.b. And equi actually is equations, actually it's become eq. So equate a value to a label. The eq directive associate a given value specified by a number or numeric equations with a required table. Using this label in subsequent code will result in direct substitutions of the associate value. So this is the syntax for the eq. So this is the results that we obtained for task 1, task 2, and task 3. So from the discussions, we know we can assemble the language by using this software is called Easy68K software, and we also learn how to write able to write the 6800 assembly language programming for execute the transfer and arithmetic data. So that's the thing. That's for lab 4. Thank you.